Welcome to our channel. In today's tutorial, we dive into the world of retail analytics. Retail analytics is essential for any business looking to understand their sales performance better and optimize their operations. We'll be covering various analyses, and I'll provide you with practical examples using Java. Let's get started by outlining our goals for today's tutorial. We will look at collecting data from sales transactions, analyzing the data to identify trends, making forecasts, and finally visualizing our findings. To do this, we will utilize Java for processing data and libraries such as Apache Commons for statistical calculations. First, we'll set up our environment. Ensure you have Java installed on your machine. You can download the latest version from the official Oracle website. We'll also need Apache Commons Math Library for the statistics part. Go ahead and add that dependency if you're using Maven by including this in your pom.xml. Once you have your dependencies ready, let's create a basic Java application to simulate sales data. For the sake of this tutorial, we will generate random sales data that represents transaction totals for a week. Create a new class called Sales Data Generator. Now that we have our Sales Data Generator set up, let's invoke this in our main application class to print out the sales data. Create another class called main. Run your application to generate and view the sales data. You should see an array list printed with 7 values representing the sales for each day of the week. These numbers will serve as our data for analysis. Next, let's analyze our sales data. We will compute the average sales, which is a basic yet powerful metric. To achieve this, we can extend our Sales Data Generator class to include a method for calculating the average. Within our main class, we will call this new method and print the average sales to the console. Go ahead and run the program again. In addition to the sales data, you should also see the calculated average daily sales. This helps businesses determine their overall sales performance over a week. Now we will move into more advanced analytics by calculating variance and standard deviation of our sales data. Variance tells us how much the sales fluctuate, while standard deviation puts this variability into a more interpretable metric. Similar to before, we will invoke these new methods in our main class. First, calculate the variance, and then the standard deviation. When you run the application this time, you should witness the calculated variance and standard deviation for your sales data, providing further insights into the sales trends. As we advance into forecasting, we can utilize a simple linear regression model to predict future sales. We will leverage Apache Commons Math to assist us with the regression analysis. First, we need to prepare our data into an appropriate format. Incorporate the Predict Future Sales method into your Sales Data Generator class. This method will calculate the predicted sales for the next week based on the sales data provided. After running your app once again, observe the predicted sales for the upcoming week. This gives retailers valuable information to make purchasing decisions and sales strategies. Now, let's discuss visualization. Data visualization helps convey your findings effectively. Although we can't create advanced charts directly in Java, we can export our data for external analysis. A common approach is to export to CSV. Add the Export Data to CSV method to your Sales Data Generator. It will create a CSV file where you can later visualize the data using tools like Excel or Tableau. After executing your program, a CSV file named sales_data.csv should be created in your project directory. You can open this file in Excel or any suitable software to analyze trends and generate charts visually. To summarize today's episode, we created a Java application to simulate retail sales data. We computed key metrics like average, variance, standard deviation, and even conducted some forecasting. Finally, we exported our findings to a CSV for visualization purposes. If you found this tutorial helpful, please subscribe and hit the bell icon for notifications about our future videos. Feel free to leave a comment down below if you have any questions or additional topics you'd like us to cover in our upcoming tutorials. Thank you for watching, and happy coding!